Hello guys, this is Amrit Manandar on behalf of Cloud IT Tutorials. In this video, I am going to discuss about routing, different type of routing protocols and different methods of routing. Let's start our video. Routing is the process of selecting the base path to forward the traffic from the source to the destination. Generally, when source and destinations are in different networks, as you can see in this diagram, source and destinations are connected via different routers, and these different routers has created different networks. In this scenario, when the source and destinations are in different networks, source has to forward the packet towards its gateway. Gateway is the router that is directly connected with the source. As you can see in this diagram, this gateway is also connected with three different routers, 1, 2 and 3 respectively, and they are also connected with different routers. This gateway is connected with router 1 with this interface, router 2 with this interface, and router 3 with this interface. Now it's open to the gateway to choose which next hop through which it has to forward the packet towards the destination, either 1, 2 or 3. It can choose any one of them and forward the traffic through the interface towards that router. To choose the base path, it will follow different routing algorithms according to the type of routing protocols they are running within it, or according to the route that has been added by the system administrator manually in this router. This process is called routing. Generally, packets are forwarded by seeing the logical address within a network package. Logical address specifies the source and destination IP addresses within the network packets. In any networks, there can be multiple network hardware devices such as routers, bridges, gateways, firewalls, and switches. These networking hardware devices can act as intermediate nodes in between source and destinations. As you can see in this diagram, this frame relay switch, this layer 3 router, this ATM switch, this layer 3 router, and this layer 2 switch is acting as the intermediate nodes in between this source router R2 and destination TFTP server. Routing generally takes place by taking help of routing tables. Routing tables maintain a record of the routes to various network destinations. Generally, routes in the routing tables are managed by network administrator himself, learning the observing the network traffic, or it can be managed by the routing protocols. In this diagram, you can see we have source and destination. When source and destinations are connected in different networks, source has to forward the traffic towards its gateway. When the source forwards the packet for that destination towards the gateway, gateway will look upon its routing table. It will check each and every route's information one by one, and it will choose the base path among them and forward the traffic for that packet through its appropriate interface towards the destination. Routing can also be done in two different ways. One is static and another is dynamic. Static routing is not a dynamic routing. Generally, static routing is the process of adding routes manually in routing table by network administrator himself. In simple networks where routers do not have sufficient hardware resources like memories and CPU, in such scenario we can use static routing. Generally, we use static routing in that type of network in which network do not get changes rapidly. But in case of complex networks, where there is multiple of networks connected with each other and networks change rapidly, in such scenario we have to use dynamic routing because dynamic routing protocols will maintain the routing tables, and if any failures occurs in the networks, routing protocols will manage the alternative paths if they are available, and it is done very quickly in managed way, so network administrator will not have to take burden of this. So in complex network topology you have to use dynamic routing. Dynamic routing is also of two types, one is distance vector and another is link state. Generally in distance vector routing protocols like RIP will comes into action. RIP is distance vector routing protocol. Distance vector routing protocols generally follow Bellman-Ford algorithm. As we know, router tries to choose the base path to forward the traffic toward the destination. Distance vector routing protocols also choose the base path among different paths that are available from source to destinations. To find out the base path, it uses hop count as the metric. There can be many parameters like delays, packet lost, or bandwidth to be used as the metric for to find the base path. But distance vector routing protocols use hop counts. So as you can see in this diagram, when the source forward the packet towards R1, R1 is acting here as the gateway for the source. To forward the traffic towards the destination, R1 has two options, either to use path A or path B. When it will forward the packet through path A, it has just to cross only one hop. But when it will use path B, it has to cross 4 hops. So distance vector routing protocols choose path A because there are less number of hops in comparison to other paths. So here path A is the best path to forward the traffic through router R1 towards the destination via R2. One disadvantage of distance vector routing protocol is that they always forward the whole routing tables towards their directly connected neighbors. Though that might not be necessary to their neighbors, they always forward whole routing tables that they have to their directly connected neighbors. So this will consume maximum bandwidth, and this problem is solved in link state routing protocols. Link state routing protocols follows Dijkstra's algorithm, and it is also called shortest path first protocols. Generally, link state routing protocols like ISIS, OSPF creates complete picture of whole network topology. Hence, they know more about the whole network than any distance vector routing protocols. So, when the links between any devices gets failed, convergence time will be very minimum in link state routing protocols in comparison to distance vector routing protocols. It means, as you can see in this figure, to forward the traffic towards this destination, R1 has two options of path A and B respectively. Generally, link state routing protocols use bandwidth as the metric. As you can see in this diagram, bandwidth of this path is much more than bandwidth of this path. Bandwidth of this path is 8 Mbps in total, while bandwidth of this path is just 1 Mbps. So, not as distance vector routing protocols, which choose hop count as the metric, link state routing protocols will choose this path by analyzing the bandwidth as the metric. So this path B will be primary path and path A will be the secondary path for link state routing protocols. So it forward the traffic towards the destination through this path. As we have discussed before, it will maintain complete picture of whole network topology. So when this link goes down, we know that this router is maintaining complete picture of whole topology. It will use this path, which is secondary path, to forward the traffic from the source towards the destination. And it will choose and activate this path promptly. It will be so quickly that convergence time is very minimum in comparison to distance vector routing protocols. Generally, it maintains three tables: routing table, topology table, and neighbor table. Neighbor table contain the information about directly connected neighbors, like in this diagram. Neighbor table of R1 contain information about R2 and R3. Topology table contains the complete picture of entire internet network. As you can see in this diagram, this router R1 have two paths to forward the traffic towards the destination. Though it has two paths, it will keep best path in this routing table, and this path it will keep in topology table. That is, to maintain a complete picture of this network, it will keep both routes in its topology table, but it will choose best path among them, that is this path B, and keeps it in its routing table. So when this link goes down, it will check its topology table and find out its secondary path and activate it and put that path in its routing table. So in this way, a link state routing protocols maintains convergence very quickly. As you can see in this diagram, link state routing protocols is maintaining neighbor table, routing table, and topology table. Link state routing protocols are generally OSPF and ISIS. There are also some routing protocols that use features of both routing protocols, distance vectors, and link state routing protocols. Such hybrid routing protocols are like EIGRP. EIGRP is Enhanced Interior Gateway Routing Protocols, and it is also called hybrid routing protocols because it uses features from both distance vector and link state protocols. Thanks for watching video. Do not forget to subscribe our channel, Cloud IT Tutorials. Keep watching our videos. Thank you.